Hi everyone. Today we'll be discussing about various chunking techniques to improve retrieval augmented generation or RAG's performance. LLMs have a context window and the number of tokens they process is dictated by it. The context windows are getting larger, which is good, but we still have to break the text down for the LLMs to process the data. And an improper breakdown may result in the data losing the context and the interrelationships between the entities in the dataset. Understanding how to chunk the text effectively can make a huge difference in the quality of outputs when we are using techniques like RAG for retrieval of information. Let's break down the different text chunking techniques and see how each one works. We can achieve this by using LLM frameworks like Llama Index and LangChain, or by using classical Python-based techniques. In this demo, we'll be exploring different chunking techniques. Each method has its strength and it's suited for different types of tasks. First, we start by loading environment variables. We used .env for managing environment variables. Next, we load environmental variables from a .env file, which contains our API keys and model information. This allows us to securely manage sensitive information and API keys. I'll be using Azure OpenAI services for this demo. This function reads the text content from an ESG document, which we'll be using for chunking. Now let's explore different chunking techniques. We'll look at how to use Llama Index for chunking. Llama Index is a framework which excels in search and retrieval tasks. In Llama Index, the data is broken down into node objects, where each node represents a distinct chunk of the parent document. We are importing necessary components from the Llama Index library. We set up the LLM and the embedding model using credentials and deployment information from the environment variables. We now initialize the Azure OpenAI models for language processing and embeddings. We will cover baseline splitting and semantic splitting methods. First, we need to load a document. We use simple directly reader to read the text file into our script. Sentence splitter is designed to split large documents into smaller, manageable chunks based on sentence boundaries. The chunk size parameter helps ensure each chunk does not exceed a certain length. This method takes a list of documents and applies base splitter to it. It returns a list of nodes, where each node represents a text of chunk from the documents. This loop processes each node to extract and collect the text content into a list. As we can see, the splitter splits the text while respecting the boundaries of sentences. Next, we apply semantic splitter. This method uses advanced techniques to split text based on semantic meaning. We create an instance of semantic splitter node parser. The embed model helps in understanding the text meaning for more accurate splitting. The get nodes from documents method processes our documents and splits them into semantic nodes. These nodes are thus stored in semantic nodes variable. We iterate through the semantic nodes, extracting its content. The content is then appended to content semantic list. This list now holds chunks of the text that are semantically meaningful. Now, the major drawback of this method is that the parser sometimes produces chunks that are too big for the LLMs to process. In such cases, we can use a mix of approaches to break down the chunk. Sentence splitter focuses on syntactically dividing text into sentences based on punctuation and simple rules. It is efficient for basic sentence level processing, but lacks deeper understanding of context or meaning. Semantic splitter node parser uses semantic understanding to divide the text into meaningful chunks, potentially based on the themes or context. It's more sophisticated and suitable for tasks requiring a nuanced grasp of text. Let's try chunking with LangChain. First, we import character text splitter from LangChain text splitters library. Next, we create an instance of character text splitter specifying separator. This means that the text will be split where there are two new lines. The splitter tries to make chunks that are up to 250 characters long. Each chunk will overlap with the previous one by 5 characters. This helps to maintain the context between the chunks. Length is used to calculate the length of each chunk. Here, false implies that we are not using regular expressions to define the separator. We are using a simple string. We use text splitter to split the text. The create documents method returns a list of documents or smaller pieces of text. So here's our result. As we can see, there are chunk sizes that are greater than the specified size. This happens because if the text between the two separators is larger than the chunk size, the splitter will create chunks that are larger than the chunk size. It does this because it needs to keep the text intact around the separators. This time we will try using recursive character text splitter from LangChain. We create an instance of recursive character text splitter with the following settings. We use text splitter to split our text, and this is how the text has been divided. In this case, if the text between the separators is too large, it recursively splits these large chunks into smaller chunks until they meet the size requirements. Now we can also try using semantic chunker, LangChain semantic chunker for semantic chunking. Here we are importing Azure OpenAI embeddings from LangChain. Next, we configure the embedding model with an API key. We then initialize the semantic chunker for semantic splitting. Now we split the input text into semantic chunks. Here's the output. This method divides text into semantically meaningful parts. The next code will help you if you want to break the data down based on the structure of the document. We are importing partition PDF from the unstructured library, which is used to extract the content from PDF files. This imports the natural language toolkit and downloads the Punk tokenizer models. These models help with text processing and tokenization. All right, this is the file that we are going to be reading and processing. This tells the function to use a high resolution strategy for better accuracy. Here through implies that this option allows the function to detect and infer table structures within the PDF. Now this specifies the model that we are going to be using for detecting tables and other structures. YOLOX is a deep learning model for object detection. Let's test it out. This will take quite some time to run because the deep learning model is running in the background. Yeah, now we are reading the first 5 elements of the list that's been generated. We get different chunks based on the sections like image, title, text, table, etc. Depending on what data we need, we can process specific sections. Now here I have printed a table. This gives us a table in HTML format. We can view it better in HTML viewer. Now let's explore different text chunking techniques using classical Python-based methods. First up, we have fixed length chunking. This is the simplest method where we divide the text into chunks of a specified length. It is straightforward, but it doesn't always respect the natural structure of the text. As you can see, we split the text into chunks of a fixed size. This method is easy to implement, but can sometimes cut off the text in awkward places. Next, we are going to be discussing about sentence-aware chunking. This technique ensures that the chunks are divided at sentence boundaries. It maintains the grammatical integrity and the contextual flow. By using sentence tokenizer, this method helps keep the text readable and coherent, which is particularly useful when dealing with natural language data. This is the output that we've received from this code. Now let's move on to semantic chunking. This approach focuses, like we've discussed before, it focuses on extracting the meaning of the text and chunking together. We have used tools here like Spacey to split the text based on semantic meaning, aiming to preserve the logical flow and the thematic consistency. This method is more advanced and helps in chunking that makes sense within the context of the content. Here, we have used Spacey instead of using LLMs for semantic chunking. And here's the result that we've obtained. Moving on to the next technique, that is sliding window chunking. This is another interesting approach. This technique ensures that the chunks overlap, which helps in preserving continuity across chunk boundaries. By overlapping chunks, we can ensure that the important information at the edges of the chunks isn't lost, which is useful for tasks that need context from adjacent chunks. Now let's talk about adaptive chunking. This technique analyzes the text deeply, making it possible to create chunks that align with the natural breaks and themes in the text, offering a balanced approach between chunk size and contextual coherence. All right, that's a wrap. We've explored various chunking techniques and how to apply them. Depending on your use case, you may have to use a combination of approaches. Each method has its own strength, so choose the one that best fits your need.